In this lesson, we're going to be learning how to use two sides to calculate the angle, which is basically using inverse trig functions. So we know the normal trig functions as sine, cosine, and tangent, but today what we're going to be doing is sort of inversing these trig functions. So instead of using one side and one angle, we use two sides and no angles. So this here is where we use sine, cos, tan. Just these go there, but then we use sine to the negative first, or sine inverse, cos inverse, tan inverse, in these type of situations where we have two sides, no angle. So we basically use sine, cos, and tan for these situations here where we have one angle one side, and we use this here. So I'm just gonna show you guys how to apply this new inverse functions we just learned. It's pretty easy, and I think it's a lot easier, to be honest, but I'm still gonna teach through and show you how to do it step by step, and then I'll put up some problems and I'll let you guys solve it. So let's just solve this problem here really quickly. So we have angle theta and we are required to calculate it. So we have two sides. Let's just use sine, cos, tan. So kotoa. So we have the opposite, we have the adjacent. We use tan. So tan to the negative first in bracket 4/7. And then we just evaluate this shift. You can also access the inverse functions by going shift, sine, cos, or tan, depending on which inverse you are going to use. So let's just evaluate this one here, which is 4 divided by 7. And that means that theta will be equal to 29.74 degrees. Okay, so that's pretty much it. That's how you do it. So if you want me to do this question again, step by step, basically the only thing I'd realistically add is, I'll just scroll up, is that tan equals O over A, and then I'd just add in the tan inverse equals, and then you get the point. So let's just go and delete this, and then I'm gonna put up another problem and I'll let you guys solve that. Okay, so this is the first problem I'd like you to solve, and I'd like you to solve for theta. So using the inverse functions, I'd like you to calculate what this angle here is, and then I'll just go through the answers with you guys. So pause the video here and then we'll go through the answers. Okay, so let's get straight into the answers. Let's first of all label the triangle and see which sides we've been given. We have the hypotenuse and we have the adjacent, which means we use cos inverse. So cos inverse bracket adjacent, which is 7/10. And then we evaluate this, shift cos, and we get theta to be 45.6 degrees. And if you got that, then well done. Now let's move on to another problem. So I'd like you to solve this problem here. And I'd like you to solve for this angle theta. That's not so theta. But I'd like you to solve for this angle here, and then we'll go through the answers together. Okay, so first of all, once again, it's just about labeling the triangle. So as you can see, we have the opposite, and we have the hypotenuse, because it's opposite to the 90 degrees. So opposite and hypotenuse means we use sine to the negative first bracket 4/12. And basically that's shift sine. And if you got 19.47 to be theta, then you're correct. Well done. I'm going to put up one more problem, but I'm going to put up a word problem. So if you can solve that, then that's pretty much it for this lesson. Okay, so this is the problem here, and now I'd like you to correctly label the sides of this triangle and also use it to calculate the angle between the ramp and the ground. So here's the problem. A ramp is 10 meters long. It has been constructed so that it rises to a point of 1.2 meters above the ground. So pause the video here, give the problem a go, and then I'll solve it with you guys. It has been constructed and rises to a point 1.2 meters above the ground. So it's 10 meters long, right? So we're going to label that side as 10, and it's 1.2 meters above the ground. So, and now we have to first of all label this triangle with the correct measurements, which we pretty much have done here. And now we must calculate the angle between the ramp and the ground. So we're looking for this angle here, angle theta. So we have the adjacent and we have the opposite, which means that we are going to be using tan. So tan inverse bracket opposite, which is 1.2 over 10. And if you got theta to be 6.84 degrees, then you're correct. Well done. That's good if you got that correct. So it was a pretty easy question. It's just about interpreting it. So yeah, that's pretty much all for this lesson. You know, just how to distinguish it is that if you have, say, two sides, right, 4 and 7, and you're asked to calculate an angle theta, then only you use inverse. So, or else normally when you have, say, one side and one angle, one side and one length, and you're asked to, one side, one angle, then when you have one side and one angle and you're asked to calculate the other side, then you use the normal SOHCAH and TOA. That's where you use it, so that's how you can divide these two. But pretty much that's the lesson summary. Yeah, so thanks for attending, guys. A like or a subscribe would be much appreciated. I'm still improving in how overall I portray my videos, and